Hello, my name is Lee Pound, and this is the AP question on our Unit 6 Statistics Quidio, which states, a large pet store buys the identical species of adult tropical fish from two different suppliers, By-Right Pets and Fish Friends. Several of the managers at the pet store suspect the lengths of the fish from Fish Friends are consistently greater than the lengths of the fish from By-Right Pets. Random samples of 8 adult fish of the species from By-Right Pets and 10 adult fish from the same species from Fish Friends were selected, and the lengths of the fish in inches were recorded as shown in the table below. Then it asks, do the data provide convincing evidence that the mean length of the adult fish of the species from Fish Friends is greater than the mean length of the adult fish of the same species from By-Right Pets? In order to answer this question, we'll use the same process we used in the advanced problem, phantoms, and we'll begin with our parameter. So I defined mu of b as the mean length of all adult fish of this species from By-Right Pets, and mu of f as the mean length of all adult fish of this species from Fish Friends. From there we move on to h, we're stating our hypothesis. I said the null hypothesis would be that mu of b is equal to mu of f, and our alternate hypothesis would be that mu of b is less than mu of f. In order to do this test, we have to state a certain set of assumptions, or A, randomization, independence, and normality. We assumed that the sample was an SRS, and then we also assumed that they were independent, or that 8 times 10, or 10 times 10, is less than the total population of fish from both stores. Then we check for normality. According to the central limit theorem, 8 and 10 are both smaller than 30, but if we check on the graph here, we can see that both stores have a fairly normal distribution to them, so we can proceed with caution. Next, we'll name the test, and in this case, we'll be using a two-sample t-test. Then we move on to actually doing the testing. This is the equation for solving for t in a two-sample t-test. We have the first sample mean minus the second sample mean divided by the square root of the standard deviation of the first one squared divided by the sample population, or number of sample, plus the second standard deviation squared divided by the sample number. And then if we plug all those numbers in, which you can get these from the calculator by plugging it into list 1 and list 2 and doing y-bar stats, it gives you a t-value of negative 0.259, and from there you can obtain the p-value, O, from the back of your textbook using the t you solve for and the degrees of freedom of 7. And if you do that, you get that your p-value is greater than 0.25. So from there you can make your decision about what your alpha value would be. I picked 0.05, and then you're ready to make your statement, or S. And you'd say, we fail to reject the null hypothesis that the average length of the adult fish from both stores was equal because the p-value of greater than 0.25 was much larger than our alpha of 0.05, making it not statistically significant.